over what's called our VehicleScape data acquisition screen of VehicleSpy. And then after that, I'm going to go into our wireless neoVI system. And then followed by that, John Mitchell will come up here and go over our cloud-based analysis tools. So this presentation, if you were here last year, if you've ever been in our Datalogger training, some of it's going to be familiar, but it's focusing on some of the changes we made for our upcoming 802 release of VehicleSpy. So start with the simple question, what is data logging? So at Intrepid, we determined data logging is using a neoVI to capture data. So it means not using your computer to capture data, using one of our data loggers. And we have three distinct ways of capturing data, when you're looking at CAN-based data at least. So we have normal mode messaging, which is normal functions of the car, diagnostic messages, and CCP and XCP. So with diagnostics and CCP, XCP, you have to build configurations to obtain those messages. Those aren't normally broadcast on the car. So we have tools built into the software that make this easy for you. And then, can you get all of this data wirelessly? The answer is yes, but it depends on what hardware you have from us. So we have a line of tools that are non-wireless tools. That would be our neoVI Fire, Fire 2, Red. And then we have wireless devices, which are our neoVI Ion and Plasma. And those tools you can get data cellularly or over Wi-Fi. But like I said, I'm going to focus on the wireless aspect at the end. So essentially, what do you need to start data logging? You need a neoVI, you need VehicleSpy, and you need some databases. Now, the way we sell our data loggers is you're not actually required to purchase a VehicleSpy license if you're going to use the hardware strictly as a data logger. So if you want to buy a fleet worth of data loggers, you don't have to worry about the associated software costs. We just basically essentially give you a license that obtains the functionality you need to set up that data logger. And then your databases, that's not a hard requirement, but it makes the setup a lot easier. And what you would be using, let's say, a DBC file for, let's say you want to trigger off of a certain value. It's obviously a lot easier if you have the DBC file loaded because you can just double click on that value that you want to trigger off of without having to program it in. Or let's say you wanted to log just a subset of messages. Maybe you don't want to log the entire vehicle worth of messages. You want to log 15 messages from one network and 5 from another. If you have the DBC files, again, all you need to do is select those messages that you want to log. When it comes to doing diagnostic logging or doing CCP, XCP, then it's pretty much a requirement that you have to have the associated A2L file or ODX file, whatever it might be. So like I said, we have the Fire, we have the Fire 2, we have the Plasma, we have the Ion. Some of our Ethernet products are capable of logging now as well, like the Red Galaxy, and also our new Gigalog. All of our products all use the same setup screen that I'm going to go over, which is VehicleScape. So it's not like if you have a Fire and then one day you have an Ion, you have two different setup windows. You could actually take that exact setup from a Fire and put it in an Ion. So everything's cross-compatible with each other. Majority of our products log to a micro SD card. The Ion and the Plasma have full-size slots, but we still actually use micro cards. We just put them in adapters. So pretty much any tool you get from us is going to have a micro SD card in it. The default size, at least on the Ion and the Plasma, is 32 gig. I believe that's what we're shipping with the Fire 2 now as well. And then, of course, we support different capacities. So if you want to put a 256 gig card in there, you can do that. We recommend, obviously, that you purchase them from us. It's not a requirement. Basically, the saying is that our official policy is if you don't buy the card from us and you lose data, don't call us to complain. But yeah, basically, we give you the format utility to set the card up, so you can use other cards. The biggest reason why we recommend that you purchase them from us is we have put a lot of time, testing time, into getting the best SD cards that are out there in terms of the data loggers. And also, when you purchase it from us, it comes pre-tested and pre-formatted. So if you were going to buy a 256 gig card on your own and format it, it's probably going to take you all day actually to format it. All of our hardware, with the exception of the older neoVI Fire and Red, you can extract over USB to the device or by removing the SD card. The Fire and Red, you have to remove the SD card. So getting into the actual setup. So Vehicle Spy is the utility that you're going to use to set this data logger up. We have a specific screen for this, which is called VehicleScape DAQ. This has been around for years and years and years, and it's kind of evolved now into our data logging application, which has also been around for quite some time, at least 5 or 6 years now. But the 802 version, we've done a lot of simplification to the screen. So the screen was getting very busy. There was a lot of text on it. So we've tried to simplify it as much as possible. We've added some new features. But essentially, this is your one-stop shop to set up a data logger. This is where you're going to load your databases. It's going to be where you choose what you want to log and then how you want to log it. And then in terms of what we support of databases, name a database. I'm sure we support it. Pretty much anything we've ever seen in the industry. If we haven't supported it, we work to support it. So everyone in here, I'm sure, knows what a DBC file is. There's another format called UEF, which is an OEM-specific one. And then for diagnostics, excuse me, there's a wide variety of different diagnostic file formats. The industry is slowly kind of moving to all using ODX. And if you're not using ODX, you're probably using a version of ODX, and you just call it something different like GDX or ENG. They're all essentially XML-based formats. Those files are what contain all your diagnostic information. And then A2L files are what you use for CCP/XCP or doing direct memory reads to an ECU. So there's one screen to load all of this. So once you load all your databases, you're then going to configure what you want to log. And that's where you're going to use VehicleScape. So what is VehicleScape? I call it the data logger wizard. That's just what I call it. But essentially, it's a configuration tool for data logging for your neoVI. It's also not just for your neoVI. You can do a configuration to run on your PC. So if you do want to record data to your hard drive, you can use VehicleScape for that. And then essentially what happens, whether you're using it for PC or neoVI, is once you've picked all your setup, there's a big button on the bottom that says generate, and that generates in the background a bunch of function block scripts and received messages in the messages editor. So it's doing all of that for you. It then opens up our compiler, it compiles it, and if you are with your neoVI and connected over USB, you hit send and sends it right down to the hardware. If you're using one of our wireless devices, you essentially just save the configuration that it made, and then you go to the website and upload it. So the workflow, there's basically a series of tabs, just like an internet browser, starting with database and hardware setup. So database setup, those are all those files I just mentioned. You just individually load each one into the appropriate network. The hardware setup is important, especially when you get a new device from us and you're using CAN. So by default, all of our CAN channels are set to 500,000 baud rate. If you are a particular OEM or supplier or whoever that's not using 500,000 baud rate, you need to go to our hardware setup and configure that. So all of our baud rates are completely configurable. They're just defaulted at 500K. If you don't do that step and you plug in a neoVI or literally any CAN tool from anybody with the wrong baud rate, you're going to crash the bus. So this is an important part of the setup. Once you do that setup once, you don't ever have to do it again unless you need to change it. So when you're on the database and hardware setup screen, there's a button at the top that says Edit Hardware Network Settings. That will bring you to the baud rate configuration, which is this screen. This is called our neoVI Explorer. Basically, whatever hardware you have plugged in will show up on the left side. You hit connect, connect to it, and then you'll see the list of all of the available networks for that piece of hardware. Once you connect to it, you get a little thumbs up icon letting you know it's connected. And then, like I said, you just individually click on each network, and then it'll have a drop down for the baud rate. And then to the database setup. So in VehicleSpy, we have what we call platforms. And a platform is basically just our terminology for a collection of databases. So you load multiple DBCs, multiple ODX, A2Ls. We save all of this under a platform name. So it's up to you to define that platform name, but this is where everything gets stored. So if you already have a platform created, go ahead and add databases to it. Otherwise, you create a new platform, you give it a name, and then that's what VehicleSpy will reference the rest of your setup. So to do that, you'll see where it says current platform. You'll hit the button that says setup platforms, which will bring you to our database setup, where you'll click on the setup button. You'll type in, you'll click add, you'll type in a name, hit OK, and then you'll have a platform. So now you'll see up here, it says data logger training was the particular name in this screenshot. And then we have our 3 sections below. So the first section is DBCs. So click on the load DBC button. And that will bring you to our screen where you add DBC files. So an important thing to know about DBC files is they're network specific. So if you have a vehicle that has 5 CAN networks on it, at a minimum, you're going to have 5 DBC files. Now, it's very highly dependent on where you work, how this works. Some OEMs, you'll have 1 DBC file for each network. Some OEMs, you'll have a DBC file for each ECU. Some they'll just split among varying things. But it's very important that you're applying the DBC file to the appropriate network. So if you have a powertrain DBC file, you need to make sure you're applying that to whatever network is connected to the powertrain network on your neoVI. If you put it on the wrong network, we have no way of knowing that, and the DBC file is used to decode data, so you're just going to get undecoded data if you don't apply them correctly. So to add, it's very simple. There's an add button. You click add, you click DBC, you select your DBC from your computer. You'll see the file path show up. And then we have this big red flashing button at the top, which you click, and that saves everything into your platform. For ODXs and other diagnostic files, that's the second area. So you'll click on the load ODX. And let's just say you're using ISO 14229. There's an import button with a drop-down. You select your UDS file format, or maybe you're using GMLAN, or maybe you're loading an A2L for direct memory reads. Whatever the option may be, you'll see them all there. So you select whatever file format it is, and then VehicleSpy will import that. Same for A2Ls. So you click import, click A2L, and then we will import the A2L. And then once you have loaded diagnostic files in A2Ls, we have a screen, which is called the ECUs view, with a series of tabs. So if you loaded an A2L file, you would have this tab called memory data, should be full of memory addresses. In this example, it's a dummy file, so there's only 1. But you should have a big, long list of memory addresses. Same thing if you loaded, let's say, an ODX file. You should have a list of identifiers and DTCs in those tabs. All right, so now we've loaded all the files. Now we want to pick what we want to log. So the next tab in our series of tabs is called the Channels tab. And this is where you pick what you want to log. So when you click on Channels, you'll get this screen. It's blank in the beginning because we have a filter bar up here that's got text in it. Once you clear out that filter bar, you'll get a list of signals, memory addresses, and whatever it is that you previously loaded will be in this list, every single item. So if you've loaded multiple A2Ls, DBC files, you could have tens of thousands of items in this list. Using the search bar, you can search for items. But essentially, whatever you want to log, you're going to either double-click it or drag and drop it over to the right side of the screen. What that does is that creates what we call a collection, or like a filtered collection. So let's say you want to log 10 CAN messages and 2 direct memory reads. You're going to move all of that over to the right side. However, on the CAN messages, you're done. On doing things like diagnostics and memory reads, there's a little bit of extra setup. So one of that is going to be, we default to what we call normal periodic rate. If it's like a direct memory read, you right-click on the message and you can change the speed. So we have basically a fast, normal, slow. And then also you can set up different conditions. So when we move into the next screen, we'll have different collections that you can set up. What's nice about that is, let's say you've got 3, 4 different collections that you're running, all with different triggers, and you want one trigger to get you CCP information, another trigger to get you just normal CAN. Essentially, you just right-click on those messages, and there's a condition set up, which I'll show you, and you say, I only want this data when this trigger's true. So that way you're not just always consistently always recording CCP data when you don't necessarily want to be. Once you've selected all of your signals, there's a very easy way to check and make sure that you've selected valid signals. So this is also important when you're doing things like polling and diagnostics. So you can basically connect your neoVI to the vehicle, and then the very last tab in the workflow is called Online. What that will do is it'll go online with the device, and you actually, again, still don't need a license to do this if you're using it just as a data logger. But what this is going to do is it's going to quickly go online and start doing those diagnostic requests or CCP requests and immediately start returning values back to you. So you'll be able to verify very quickly that you've picked the appropriate signals. It's a very common mistake with a lot of customers where maybe you used an outdated A2L file. So before sending out a logger with the wrong A2L file, which means you're going to get no data, you can quickly verify it with this. So right from the screen, you can see what's updating, and then down here I have one that's not updating. So obviously, whatever ODX file I used wasn't the right one. I'm not returning any value at all. So what I did here is I just took a screenshot from our new 802 views. But like I said, at the end of this, I'm going to go through an actual setup and load it. So you'll get to see what the entire screen looks like. But right at the very top, we have 3 different message collection options. So we have just straight up message capture, what we call a bus query. What a bus query does is that generates an XML file of DTCs and any DID that you select. That is then stored to the neoVI and also uploaded if you're using a wireless neoVI device. And then we have histogram option. So you choose what type of capture. I'm going to focus on message capture for this example. Right below that, you give it a name. So that is going to be your triggered name, essentially. So in this one, it's called log all, which is I'm just logging everything all the time. Another common one is a driver trigger. Maybe you put a button on your steering wheel, or we have a device called the neoVI-MOTE, which you can press the button. It'll trigger a log. The mic's nice because you can actually record audio into the log as well. Right below that is your collection option. So the default is just to log everything all the time. Below that, if you select that, it'll log only the items from the previous channel screen. And then we also always timestamp the file. So a common question I get for the data loggers is, well, what happens when the data logger gets full, or are you always overwriting all the data? When you run the extraction, you'll get a series of files based on your setup, all with your name you gave it and then a timestamp. And then overall for the entire SD card, it's just a first in, first out buffer. Also, when you do selected messages, you can force a decimation rate. So this is very common for people that want to do long-term, like maybe they're just doing fuel economy logging over a term of like 6 months. You don't need to log a whole lot, and you don't need to know everything every 10 milliseconds. So you can force a decimation rate and then that way you can get a longer time frame on one SD card without overwriting anything. From there, how do you start logging? So you have three options here. Immediately, which just means as soon as we're powered on and there's vehicle traffic, we're logging it. The second option is using a trigger expression. So that could be literally any trigger expression from the vehicle. Anything, utilizing your DBC file. You can also use diagnostic information. So basically what we'll do is we'll just continually pull for that parameter that you want to trigger off of, and once it becomes true, we'll trigger. Like I said, we have a neoVI-MOTE trigger button. You can use that. We have a neoVI-MOTE, which you can use, which is another trigger type device. And then we also have what's called using a trigger expression, which I'll show you what that means. So when you use a trigger or a trigger expression, you have different options for capture. One of those options is a pre-post capture. You can do that on a message base or a time basis. So most people use the time basis. And what that is, you can say, whenever the trigger's true, I want 30 seconds of data from before it was true and 15 seconds of data from after it was true. And then what we do is we just cut the file based on that time basis and save it. So the default option, if you, let's just say, did trigger immediately, is we'll log 50,000 messages. That's the default setup. Now, that doesn't mean we're going to log 50,000 messages and stop. It just means that each file is going to be 50,000 messages in size. You can make this whatever you want. Just be mindful of the file size. So we have a little estimation of what the file size will be. So 50,000 messages is about 3 megabytes. Nowadays, that's probably 5 seconds worth of data in a car. You can also stop on an expression. So maybe you do just want one gigantic trip file. You could say start when ignition's on, stop when ignition's off. The pre-post collection looks like this. So you'll enable pre-post, and like I said, you have an area where you can do by time, which is shown here, or by number of messages. So essentially, you just type in the number of seconds you want from before and after your trigger condition. And then the restart options, so like I said, by default, we always rearm the condition. So that means we're always logging. We don't stop logging. If you did want to actually stop logging after you triggered one time, you would change this to do not restart the collection. So that would run at one time, basically per power cycle. If you leave it the default option, we're always logging. If you had a trigger condition, we met the trigger condition, we log the data, basically we just rearm the trigger and we wait for it to happen again. The reporting, so by default, the LED reporting option is turned on. Essentially, we've had a red and a green LED on pretty much all of our products, at least since I've been with Intrepid, and they've almost always meant the same thing. And that is, when you're running a Core Mini, which is a configuration that we're building, is the red LED is going to blink at a rapid rate. That is a clear indication that your neoVI is doing something standalone. Because if your neoVI is not running a collection, the red LED is not on at all, unless you're connected to VehicleScape. It'll be just the green one blinking. The green one will blink at a slow rate when we're actually storing data to the SD card. So that's, again, a clear indication that we're actually logging data. And then if you're using a pre-post collection and you're in a post-trigger situation, the green LED will blink rapidly. Our neoVI-MOTE you can use as well as like a little mini display to display any signals that you pick on the screen. Of course, our new VividCAN is a good add-on to our data logger now as well. And then power management. So a neoVI Ion with, let's just say you load it up, you've got 2 Fire 2 VNets in here. It's going to run about an amp in your vehicle. So obviously that's not something you want on when the vehicle's not on. So by default, this is actually not default off anymore, it's now default on. We have power management options. So the default option is after 2 minutes of no vehicle network traffic, we shut down. We go into a low power state. It's very dependent on which product you have and which product configuration you have for what that low power state is. But it's generally I would say 20 milliamps or less. So the Ion is probably the highest one currently, which is in that 20 milliamp range. But some of our other products go down. I know the Fire goes all the way down to about 4 milliamps. What then happens is as soon as there's vehicle network traffic again, we wake back up and resume logging. Also by default, what we'll do is we'll start a new file when we wake up. So let's say you went to sleep in the middle of a 50,000 message log. To prevent having, let's say, a 10-hour time gap in your file, we'll start a new file when we wake up. We also have two different wake modes, normal and fast. So again, it's up to you on what you want. Fast will wake the logger up faster. Again, it's depending on what hardware it is. And however, that does require more current draw. And then for our wireless devices, we have some different timeouts for power management. So, let's say you did an 8-hour drive, you're obviously going to have a lot of data to upload. So you're going to want to give the logger some time to actually finish uploading that data. So that's where the overall timeout comes in. Our default is an hour. I'd say most of my customers probably put 4 hours in there. And that gives the logger time to upload all of its data. The connection timeout, that means if the logger doesn't get an internet connection, we're just going to go ahead and shut down. Because if a car is sitting stationary, doesn't get an internet connection for 10 minutes, it's probably not going to get one. And then beyond that, we have a voltage cutoff. So let's say you did have all these timeouts set up, but we do notice your battery is getting low. We will forcefully shut down at that point as well. At the bottom here, this is another very important piece of power management. If you're using the neoVI to do diagnostic logging, that means we're transmitting messages. So you need to give us a condition to stop transmitting. Otherwise, we're going to keep sending canned messages out. We're going to be awake. We're probably keeping other ECUs awake. But nothing's ever going to go to sleep. So you need to give the neoVI a condition of when to stop doing those transmits. And in the very end is basically generating the script. So there's a couple of things that happen here. We generate a decoding database. So basically everything that you've chosen in the channels tab or a trigger, we generate what we call a VSDB file, and we save that to the SD card. A VSDB file is every signal that you've used created into a database. So it's in one single file format. This is useful because let's say you set up the neoVI, you send it out. Let's say maybe you send the car to Arizona for hot weather testing, and there's going to be a different engineer there looking at the data. Maybe he doesn't have the A2L file you used or the DBC files you used, or he doesn't know which ones you used. When he extracts that data, he's going to get that VSDB file. He can load that into VehicleSpy, and he'll be able to view and make sense of the data. It doesn't give him the entire files, just exactly what you used and what you logged. The other thing we do with that file on our wireless side is we upload that to the website, and we have tools built into our web pages that translate it and create DB files and give you some quick view options so you can quickly see what messages you've logged and some average statistics of those messages. If for some reason you don't want that, some people don't want that on the logger because it could be a security risk. Maybe you don't want someone to extract the data and then also have some database decoding. So if you don't want that to happen, you can turn that off. Another feature we're going to have starting with our 803 release, and this is mainly being driven from Europe because of some new data privacy regulations, is you will have the ability to actually password protect these files. So we'll store in what we call our VESB instead of VSB file, so it's an encrypted VSB file. So you will have to have a password to actually extract the data and view the data. So when you hit generate, it'll build function blocks in the background based on all the selections you've made, opens up our core mini generator, and as long as you've got all good green lights, you're ready to send it to the device. So from here, you can send it over USB, or you can export it as a Wi-Fi file, which is what I'm going to demonstrate to you, and then go to the website and upload it. If you did it over USB, essentially you'll see a progress bar on the bottom. It happens very fast, like in this screenshot, 348 milliseconds, so it doesn't take a long time to load. And you're good to go. So the default operation is you send it to the device. It's actually not running, unless you had checked this box here that says run Core Mini after download. By default, it's not running, and it won't run until you power cycle it. Another important thing to note on that is when you power cycle it, you have to make sure USB is not connected. If USB is connected, it still will not run. Having USB connected on the power cycle always stops Core Minis from running. And that's on purpose because it's a way to forcefully stop a Core Mini if you ever had to. If we didn't have that option and you had some bad script running that was in some sort of infinite loop or something, you would have no way to stop it without the USB connection. Now, you can unplug USB, power cycle it, the Core Mini will run, and then you can re-plug back in USB and connect to it. And that's another big perk of our tools. I'm not aware of many data loggers that do this, and I know our biggest competitor in this area does not do this, where you can have a data logger in your car running, recording data. You can also connect VehicleSpy to it at the same time. So you can still do online analysis with your data logger while it's logging data. So what's next? Of course, getting your data. So in our manual mode, you're going to acquire the SD card in one way or another, or if you're using one of the newer devices, you can just plug in USB. And essentially you'll get a volume show up on your computer. So if you took the SD card out, that'll be called logger. That's what all of our SD cards are called. And on that drive is a series of what we call VSA files. That's our file system. You don't want to mess with that. You don't want to copy that to your computer. What you do is you use our extraction process. So if you did go look at the volume, you would see a README file, which will tell you to do that, and then a series of these log data files. But what you're going to do is you're going to go back to VehicleScape and click on the Extract Export menu, or button. And in the source data area, you're going to see either your SD card, or let's say you plugged in a neoVI-ION, it'll say neoVI-ION and the serial number. From there, we're going to populate a start time and an end time. So that's basically the time we started logging to the time we stopped logging. There's slider bars next to that. So let's say you've got 10 days worth of data on this SD card, but you know that there was a certain issue that happened on day 3 within a 1-hour time frame. You can move those slider bars to that 1-hour time frame and then hit extract, and we'll extract just that portion of data. You certainly can extract the entire SD card too if you want it. So the data source will show up here, output data, so that's where you want the data to go. And another feature once you extract it is we have export options. So by default, when you extract from us, you're going to get a VSB file. That's a VehicleSpy binary file. It's what VehicleSpy uses to view data. Let's say you want to translate it into an MDF file. You'll see down here at the bottom, MDF is one of those options. You'll click on that option and hit export. We'll translate it into an MDF file. Another really cool thing with the exporter is let's say you logged 100 signals, but you only wanted a 5-signal MDF file. When you select that MDF file, we're going to populate all of the signals we logged on this right area here. You can just pick out the 5 you want and hit export, and we'll make a new file that has just those 5 signals. So how do you know that the data is good when you run the extraction? As long as you don't get any error prompts, no red error prompts in the utility, that means we extracted good. If there was any dropped messages or file corruption, the screen will tell you that. We also generate a notes.txt file, which gives you information about all the data we extracted, how many messages we logged on each network, vehicle information, firmware information, all sorts of things in that notes file. So now you've got the data. What does it look like? So like I mentioned, it's going to have whatever you named the collection and a timestamp. So essentially, if you extract it to your PC, you'll have a folder on your computer that's going to say extracted data and the time of which you extracted that data, and then a big collection of VSB files. Again, all with your collection name and a timestamp. All right, so before I go into the wireless side, any questions? Yes? CSV. Yep, we can export to CSV. We have two different types. We have what we call our message data CSV, and then we have what we call a CSV signal data file. So one has message data, one has just signal data. But yes. I will warn you though that exporting to CSV is going to give you gigantic files. So unless you have recorded your data in small chunks, you don't want to try to load a 2 million message CSV file. You probably won't be successful. Rob? No, not since Excel 2007. It'll load big files, it takes forever. And like I said, if you had like a 100 megabyte VSB file, it's probably going to turn into like a 600 megabyte CSV file. Any other questions? Is it, I'm sorry, a flat format? I can't hear you, I'm sorry.